Welcome back. In this again it's a continuation of the previous lab. In this lab session we will talk about the 8th program, that is a quadratic equation. Write a program to find the roots of the quadratic equation. First we will discuss the explanation, and then because once we will come to know what are the inputs are required and process and output, so it's easy for us to implement. So, input is always we need to provide the coefficient values, that is a, b and c of the quadratic equation. That is the important thing, because these are the coefficients, and we know the formula of quadratic equation, b square minus 4ac, right. So, b is there, a is there, c is there, 4 anyway is a constant. We need to apply any time, because before that we need to find out, we need to get the input of these ABC, and then we need to find out the roots, whether it is a imaginary or complex part, all those things. So, we need to calculate discriminant by using this formula b square minus 4ac. Based on the discriminant value, if it is greater than 0 or equal to 0 or less than 0. If it is greater than, the discriminant value is greater than 0, then we can say two distinct real roots. If it is equal to 0, then one is real root. If it is less than 0, roots are complex conjugates. That is how we can compute the roots using the quadratic formula and handle the complex roots if needed. The output is, the program prints the roots of the quadratic equation, either real or complex. See the example here I mentioned. So, the quadratic equation is x square minus 3x plus 2 equal to 0. Once we apply these ABC values to that of b square minus 4ac, we get some discriminant value, that is 1, which is positive. Again the roots, we are just checking the roots, whether what type of roots are, and finally we got these values, and we can say these are the roots, and you need to print. And always we need to change the values of the coefficients as a input based on your input. That's how we can solve the quadratic equation. So, this is a simple program to implement this quadratic equation. For this, because most of the calculations here involve the mathematical calculation, that is, I think as in the theory we mentioned, we need to, whenever your code or program involves any the mathematical operations or the calculation, we need to import the packages, or we can say the modules, which is related to the mathematics. That is nothing but the math module that we need to include into the code. Wherever you are implementing to that particular program, you need to include. For that reason, we are using the import statement, import of math. So, all the mathematical libraries or the modules will be included into the code, this particular code. For this, there is a function called def find underscore roots. So, as already mentioned, input should be the 3 coefficients a, b, c, and we need to calculate the discriminant. Discriminant is b square minus 4ac. Once you apply all the coefficient values to this particular formula, you will get after the computation you will get some result. Now, I am just we need to check what is the discriminant value, whether it is a greater than 0 or equal to 0 or less than 0. If the discriminant value is greater than 0, then we need to check this is a root 1 is equal to minus b plus square root of the discriminant values, whatever the value you get, that is a square root of that by 2a, and another root 2 is minus b, that is one we need to check both, right, one is minus, another one is plus. So, again the discriminant square root of discriminant values by 2a, and we are returning both root 1 as well as root 2. Else if it is not greater than 0, then it whether again we need to check whether it is equivalent to 0. Root equal to minus b by 2a, again we are returning the root. Else if not equal to 0 and greater than 0, then again we need to check the complex root. The formula is same, real part is equal to minus b by 2a, and imaginary part is square root of discriminant by minus discriminant by 2a, and return, we need to return both real plus imaginary comma real minus imaginary, we need to mention both is a we need to return. So, say this is an example, a value directly I am hard coded, probably you can just take the input like by using the input function, a equal to 1, b equal to minus 3, c equal to 2, then I am passing all those values as a parameter to this function call find roots. I am just checking the root value, we will get some roots. If equal to 2, then I am just saying roots are whatever the roots you got. If it is only 1, that value you need to print, else you need to print both. So, this is the simple way to implement the quadratic equation. So, in this program as mentioned, the important thing is you need to remember three inputs we need to provide, that is A, B, C coefficient. Once you get the input these three coefficient, then you need to calculate that B square minus 4 AC, and then we need to check a discriminant value we will get. Through that, whether it is greater than 0 or equal to 0 or less than 0, based on that we need to check both real or imaginary, nothing but we need to return the roots of that. That is about the implementation of the quadratic equation. Thank you.